They're not possible. They are there already today. There is not a pharmaceutical company that doesn't have a theory division that works on trying to predict how a molecule will interact with the target in the body. This means that all development of new pharmaceuticals has a background in theory. When you are looking at devising new chemical reactions, when you are trying to create a new hard material or a new material with specific properties, if you want to optimize the electronic properties of material, the magnetic properties of material, you always start out with theory because it saves you so much time in the lab. Now, theory is not perfect. You still have to do the experiment. But the predictions that theory make are becoming so much more powerful these days that we can perhaps save 90% of the experimenting and concentrate on the 10% where we know that the most important results will lie. So we save a lot of money, we save a lot of time, and we save a lot of effort by doing the theoretical homework first. It's like in the old days when everyone told you have to read the literature. Now everyone will tell you you have to make the calculations.
So now you just sit by the computer instead of being in the lab most of the time.
There is some truth in that, although of course what happens is that we can now turn to ever more complex systems. We can always devise a system that is so complicated from the experimental point of view that theorists still are struggling to keep up with us. But on the other hand, they keep challenging us. If you look at the physics prize for graphene, for example, now the extraordinary properties of graphene were predicted before by theorists. This is why the experimentalists tried to make the material, because it's no simple matter to make it. They tried to measure the properties because they knew that there was something interesting in there, and they succeeded. But it was all thanks to the theory that someone even tried.